Okay, welcome to your notes on vertical and horizontal shifts. We're going to start off with a horizontal shift, which, as you know, horizontal means that you're either going left or right. And in function notation, horizontal shift occurs when you start off with f of x and it translates into f of x plus h, where h can be any number. And so this horizontal shift occurs when this number inside of the parentheses is either added or subtracted to x. Okay, so for our first example, we have f of x equals x squared, and we're algebraically going to find f of x plus 3. So first, let's just focus on this f of x equals x squared. You're going to type this into your graphing calculator, look for the vertex, and pick 3 values to the left and right of the vertex. So go ahead and pause the video now so that you can come up with your t-table and make sure that it matches mine. Okay, so here's what you should have for your t-table for f of x. You should notice that your vertex is 0, 0. So you can pause the video again and graph this function off to the right. Now make sure that your graph has arrows, because it does go on forever, and that you label your graph with the function, whether it's f of x, or you can write f of x equals x squared, because you will be graphing another function on here, and so it's very easy to get confused. Now for the next part, it says algebraically find f of x plus 3. So we can't just type in f of x plus 3 into the graphing calculator. What we have to remember is that this stems from function notation, and so this number this concept inside of the parentheses, this x plus 3, okay, that is the x value. That's what is substituting in to the function rule and replacing any x that you had in the original equation f of x. So if we're finding f of x plus 3, we are going to replace x with x plus 3. And so what that looks like is x plus 3, the whole thing squared. So if you want to type in to your graphing calculator in parentheses x plus 3, the whole thing squared, you can, and your calculator can handle that. Or if you wanted it to look more like a trinomial like we're used to, you could double distribute x plus 3. So you would write it twice. You would double distribute. And by doing that, you would end up with x squared plus 3x plus 3x plus 9. And by combining like terms, this would be x squared plus 6x plus 9. So either way that you want to write it, whether it's the standard trinomial, x squared plus 6x plus 9, or whether it's this x plus 3, the whole thing squared, they're equivalent, they mean the same thing, they'll give you the same table. So either way, pause the video now, figure out your vertex by typing in this equation into your graphing calculator, and again, pick 3 values to the left and right of the vertex. Now, if you look at your table, you'll notice that your y values are exactly the same, and that the only thing that changed were your x's, which should happen in a horizontal shift because the y values are staying the same, but the x's are moving, whether it's to the left or to the right. So go ahead and graph this table of values if you haven't already. So here's what your graph should look like. Again, make sure that you have arrows at the top and that you've labeled your graph. You can label it with just f of x plus 3 if you'd like. Now, to describe the transformation, well, we know that it's a horizontal shift. So the question is, did it move left or right, and how many units exactly did it move? So since f of x is our original graph, we can see that f of x plus 3 shifted our graph 3 units to the left. So on that line, to describe the transformation again, you can write that it's a horizontal shift 3 units to the left. Now, our next topic is a vertical shift, which we know that with a vertical shift, our graph is either going to move up or down. So the function notation is that a vertical shift occurs when f of x changes to f of x, and then we have plus k at the very end. So if it's horizontal and it's shifting, the numbers inside of the parentheses are going to be added or subtracted, but if it's a vertical shift, the numbers at the very end will be either added on or subtracted at the end, outside of the parentheses. So if you notice on number 2, we're still graphing this f of x equals x squared function, which is the same thing we've already done in number 1. So you can just copy down that table and graph that function just like you did on number 1. So again, make sure that you have arrows on your graph and that you have labeled your graph with f of x. Now, for the next part, algebraically find f of x plus 3. Well, we know what f of x is. So we know that f of x is, in fact, x squared. So f of x plus 3 will just be x squared. That replaces the f of x, and then we just have plus 3 at the end. So we can type this into our graphing calculator, this x squared plus 3. So go ahead and type that in to your calculator and figure out what the vertex is, and pick 3 values to the left and right of the vertex again. So here's what your t-table should look like. Now you can pause the video again and make sure that you can graph these points. And you'll notice that you have arrows again on your graph, that you have labeled your graph with f of x plus 3. Whoops, the plus 3 should be at the end of the parentheses. So like that, with f of x and then plus 3 at the end. Now, to describe the transformation, well, we know this is a vertical shift, so the question is, did the graph move up or down, and how many units exactly? Well, the blue graph is our original, that f of x, so we know that the original f of x graph has shifted up 3 units in a vertical shift. So that's what we can write on the line, is that it's a vertical shift up 3 units. Now, there is a back to the notes, so right now you're going to try to see how much you can do on your own, and if you need help or if you get stuck, feel free to call us over and we can help you figure out the back of the notes.